this is 6.3.3. Although we have seen that the Z transform is a very nice tool to use, and we can easily convert the Z transform to DTFT representation, we must now see that not all signals have Z transform. Look at this signal. This is the most common sinusoid, but it is everlasting. N will go from minus infinity to infinity, same as cosine omega naught n. They, however, do not have a Z transform, because if you look at the Z transform carefully, the table is not using sine omega naught n. It is using sine omega naught n u of n. So it is only the causal sequence that have the Z transform, or the anti-causal sequence. But an everlasting sinusoid does not have a Z transform. And the reason is that you realize that when we try to perform Z transform of this, the ROC is empty. Okay, this explains why over here. And then you must be wondering, if the Z transform of the sine omega naught does not exist, why does the DTFT or DTFS have a Fourier transform of sine omega naught? And the reason is basically we are going to use the delta. We admit the use of the delta function in the representation of the DTFT and DTFS. Or I should say, we admit the use of the delta function only at the DTFT. In the DTFS, it is only at the particular frequency Ck. Right? Now, interestingly, if you say that xn equals to sine omega naught n un, then this has a Z transform. Okay? And does the Fourier transform exist? So if this is the Z transform of this, then what is the Fourier transform, discrete time Fourier transform of this? So it is a little bit eccentric. It looks exactly like this. We will not have a chance to play with such a esoteric signals for the DTFT. We'll just use the Z transform and use it from here. Notice that, you see, the Z transform has a pole at 1, so it is right on the unit circle, so it does not include the unit circle. That is why we say that the DTFT does not exist. But you can do a lot of other tricks to figure that out, or to get the sine omega naught n un, to get it to represent it as this. Okay, but this is just FYI. We are not going to be playing with this level of signals at all in this course. Thank you.